My name is Robert Tickleman. I'm a premier field engineer for Microsoft, and my job is to go out to the field and work with our customers in the deployment of their technologies. And that's what Pat and I are going to be bringing to you over the next couple of days. It's just not the marketing slides and the technical pieces. We're hopefully going to be bringing the stories from the field and the actual production uses. For the better part of 3 years, I've been working in the field with our partners and with our customers in the deployment of their Azure Stack Scale units. And they're planning the processes with some of the biggest customers, of which we have some capability to talk about.
Yeah, so I'm Pat Telford. I'm part of Microsoft Consulting. Like Robert, I've been working in the early adoption program here for a couple of years now. So we've talked to hundreds of Azure Stack customers. Not us personally, but between us, we've talked to a fair number. And we've seen firsthand some deployments. We've worked with some Azure Stack adopters after they've got their scale units deployed. Why Azure Stack? How do you express its value? And to me, when I think about Azure Stack, there's really two parts of magic that sit underneath there. One is what we talked about in the Intel presentation earlier. It's the engineering that's gone into producing that very robust, highly tested, wheel-it-in appliance type hardware experience. So we're hoping to take out of the hands of the people that are deploying Azure Stack any of that variability that might be, oh, I've got the wrong firmware version on my network card that doesn't work with the software stack. Hopefully that's what expressing an appliance that's already pre-tested gets you out of that game of mix and match hardware and firmware levels and making sure it's all consistent. So that's one area where there's tons of engineering, and that's part of the magic of Azure Stack. The other thing that you should try to express when you talk about Azure Stack is on the software side. The real magic there is this Azure Resource Manager. So it's the thing that you talk to when you want to do anything with Azure Stack. And it's the same thing that you talk to when you want to do something in Azure. And that's where the real magic is. It's not like saying, oh, I have a server virtual machine that I would deploy in public cloud in AWS or in Azure. And if I want to, I can also deploy that virtual machine onto my VMware estate. Well, of course you can, but there's a whole bunch of extra effort involved there. The idea that a developer can express in a simple template, hey, I want a Windows Server 2016 virtual machine, and they just point that at Azure and they get one. They can point that exact same template, that Azure Resource Manager template at Azure Stack, and expect to get the same thing. That's where the real magic is. So we'll spend a lot of time talking about hybrid applications and how Azure Stack is Azure. You interact with Azure Stack the same way that you interact with Azure. Okay, so let's jump back and think about what happens during an Azure Stack deployment. So we're going to talk about gathering the prerequisites, getting the information, what happens during the deployment itself, and things that you should do immediately after the deployment. So first, we'll talk a little bit about some terminology. So in terms of Azure Stack itself, we're going to be using these terms throughout the next couple of days fairly liberally. So let's just get them straight at the start. So a cloud is a single instance of the Azure Resource Manager. So Azure Public Cloud is all one cloud, except there are some specific government deployments, right? So in
sovereign regions.
Yeah, in Germany there's one, in the US there's one, in China there's one. Those are independent clouds because they have a separate Azure Resource Manager. So you'll notice in public Azure, if you are connecting to something, you connect up to Azure with your Azure Active Directory account, and then you just point at whatever region you want to deploy stuff in. You can deploy stuff into all the different regions from one connection. The same is true in Azure Stack. Azure Stack is a separate deployment of Azure Resource Manager. I'm going to come back to that in a minute. So the next thing to think about is regions. You'll know in the public cloud of Azure, we have a region US West, we have UK region, we have an Australia region, etc. So that is a set of computing resources that share a location. The same would be true for Azure Stack. If you deploy a second region into Azure Stack, you can have it be in a different data center. so that you can have multiple regions under a cloud, sort of, which I'll come back to. And then at the bottom of this tree is a scale unit. So we'll talk about a scale unit, or we might call it.
Yeah, for me, because there's three terms that people use interchangeably here, and they mean three different things. There's Azure Stack, which is a product and relates to our entire product of Azure on premises for you. There's a thing called a stamp, and there's a thing called a scale unit. A stamp is what a vendor does specifically to their hardware to generate the general product of Azure Stack. Because how Intel or how Dell versus HP versus Cisco, the drivers, the things that they have to do to their physical hardware to create this generic product, Azure Stack, so that a Dell Azure Stack looks the same as an HP Azure Stack as it does for a Lenovo Azure Stack. What they had to do to generate that is different. And so that's what we refer to as a stamp. And so I'll say, how many stamps do you have? They go, what are you talking about? Because if you have two different hardware from the same vendor, you may have two different stamps. One is configured for SSDs with lots of cores versus one that has got physical hard drives and maybe less cores. That's two different stamps that you're working with. So it tells me something different as a user of your deployment. And so a scale unit is your customized deployment of the product Azure Stack through the stamp process from a vendor. Make sense?
Stamp was the word that was eluding me there.
Yeah.
So I said all this, but now I'm going to backtrack a little bit, because today, although the architecture for Azure Stack is planned, today each individual Azure Stack appliance, each scale unit that you buy, is in its own region, and the Azure Stack Cloud supports only one region. So right now, if you buy multiple Azure Stack appliances, you're going to get multiple regions in multiple clouds. So that means from a user standpoint or an administrator standpoint, there's no single pane of glass that can administer multiple Azure Stacks deployed today. You would have to run up your admin console pointed at one of your clouds, and it would have one region in it and one scale unit. And if you wanted to administer the other ones, you'd have to repoint your portal or your PowerShell over to those other ones. So this is the proposed architecture, the future architecture. But today, every Azure Stack that you buy, every scale unit is in its own region, in its own cloud.
And,
all make sense?
And we've announced multi-scale unit regions, but it's not
available yet.
Officially released yet. There's a question?
Yeah.
The multi-scale unit is not independent scale units, it's like scale unit extension.
That's what's likely coming next, is the ability to.
Really multi-scale unit, or is it scale unit extension?
That's debatable. You're right. It's almost like making a bigger scale unit than is available today by slapping some hardware on the side. But the intention is that you should be able to produce this picture eventually. So you would have multiple scale units independently sat side by side in a data center, forming a region, all combined in a single cloud that you can manage through one endpoint or one portal experience.
Are we working with any third-party vendors that already have? I don't think we can either confirm nor deny what, we're not at that pay level. It may be happening, but I have.
But your question, I think, the question was, are you working with anyone to produce something that looks like this? So there's another answer, which is the applications that you deploy on top of Azure Stack, they could well work with the same application deployed on your second and third Azure Stack, right? Like in the same way that you could make a Kubernetes cluster that spans across multiple servers today. If those servers are stood up in different Azure Stacks, then that can work the same way.
So, sorry, I did remember the questions. As I understood it from previous, the Azure Stack shows up on your Azure bill, right? If you were, it's one billing, one experience. So how does that go with if I have 2 or 3 stacks?
Yeah. So we'll talk about registration shortly. So that's all to do with where you register.
So the question is, while Azure Stack shows up as a billing unit within your Azure subscription, how is this going to work? So answer number 1, it depends. Yeah. Because It's going to depend. Are you registered or are you running disconnected? Because if you're going to pay on a pay-as-you-go versus are you on a consumption model, there's a conversation we're going to have later that is going to fundamentally separate that billing model. But yes, that billing is going to come through, and we'll take a look at that if we can readdress that at that module.
What I was getting at was you were saying you can only have one stack, right? You can't, or if you have multiple, you have to point different administrators.
Yes.
I just wondering how if they're islands like that, do they all roll up under one cloud tenant?
They can all be registered under one subscription in Azure, which means you would get one bill that said Azure Stack, one bill.
Show up as zone.
Yes, yeah,
Yes.
they'll have different names underneath there. Yeah.
Just another wrinkle.
Yeah, so if you don't register it, or if you have two different subscriptions, it's going to show up as under two different bills or tenant.
Okay, so what's inside?
Can you go back to that previous slide just for a sec?
Yep.
I want to make this tangible in a real world example. So we've got a company, it's a telephone company in New Zealand. If you know that the nearest data center is in Australia, big hunk of ocean, they say there's no way that our Australian businesses, big law firms are going to run in Azure because that network connection goes down. So what they're doing is they're building in the North Island and South Island, two data centers that they're going to deploy for Azure Stacks. And their stated goal is to become Microsoft New Zealand. So they're going to build these two regions, going back to what we've got here, one in the North Island. So just like you do in Azure, you can connect to New Zealand company.azure stack or whatever the cloud name is that's going to connect to that. And you can go to either the North Island or the South Island, or combination thereof, just as you would in Azure. Now there is one limitation that we want to make sure that you're familiar with here, because this is another decision that they had to walk through. So this is the work that you can do with your customers. Currently, the regions are vendor specific. Because of this thing called the TORs, we're going to get into this, the top of rack switches that brings them into the aggregate switches that allows the region to look as if it's a region. So they wanted to go to two different hardware vendors. So now they have to have two regions in the north, one for vendor one, one for vendor two, and two regions in the south, one for vendor one for vendor two. Now they look like one great big cloud, potentially, but they're stuck on this limitation of they're at different endpoints. So they have to find some way to say, I have 4 different endpoints now, how do I obfuscate that from my customers? It's the same conversation I'm having with Chevron as we walk through the conversation to say, are we going to roll up into one Azure tenant so that all of Chevron around the world reports into one Azure bill? Or do we have multiple Azure subscriptions for the different divisions and they want to report up into their billing models? These are the kind of conversations that you want to have with your customers and make them be aware of what those decisions are, because in some of these cases, the only way to change that would be to redeploy the scale unit. So you want to make sure that this planning, and while the limitation, so that's what it was, they've decided to build 2 scale units right next to each other, but they built them in 2 different regions because they know that they're going to move that second scale unit to the South Island when they eventually build that data center out. Because they really wanted to put them into the same region, but they couldn't do it because we only supported a single scale unit region.
And they gave them some sort of neutral name that didn't expose, like they didn't say it's Dell region or Lenovo region or anything like that.
So we could take Azure Stack and spin up little Azure data centers on all these tropical islands that don't have any Azure.
Correct. I've been in some Nordic countries that we don't have data center plans. So that, we've got governments that was alluded to earlier that are spinning up because we've got sovereign clouds in Germany because we've got a public cloud data center in Germany that meets a lot of the data sovereignty requirements. But guess what? The Germans said no, that we have certain data that can't live there. So we had to build a sovereign cloud for them. But how about all those other countries that don't have those sovereign clouds? This is, I was just recently in France and they're doing something similar for the French government. We're from Canada, the 2 of us. We've got 2 data centers in Canada, but still there's some Canadian data that they're building a sovereign Canadian cloud using Azure Stack as the model to give that. And so again, in that one-arm development, whether I go to Azure Canadian deployment or to our scale unit, it's all exactly the same.
So your question is really, why did you go to Norway when you should have been going to the Cayman Islands instead?
Yeah.
Yeah, and that's interestingly, out of the early adopters, Normally when we run early adoption programs for things like Windows Server, it's really heavily focused on the US, because the US customers, there's some that are flying ahead and are really interested in them, in the new capabilities. With Azure Stack, most of the early adopters were in unusual places, right? So in Scandinavia, that we had multiple customers in New Zealand, and not so many in the US, because in the US we have public data centers already. So Azure Stack has a really good play in those locations where public cloud is a blocker because of like legislative reasons.
You know, and even in the US, you know, we had a government agency here locally, and they said, oh, we got to have Azure Stack, we're going to build our own. I went, you got some of the best data centers in the world right here. And so we kind of played along, and we said, tell you what, take a whole bunch of ASDKs, free, start your development, because it's about not where, it's about how. So they started developing their apps in ASDK for free. And when it came time for them to deploy it onto Azure Stack and get the pricing for it, like 35 scale units, they went, holy cow, that's super expensive. We'll just go to Azure. We went, perfect. But Hawaii, guess what? No data center there. You know, that's a great opportunity for state and local governments in Hawaii. Alaska, when we talk about edge connectivity, great connectivity, because while they're part of the United States, like they're on the fringes. So those are the kinds of environments that, you know, are key for the success of an Azure Stack deployment. Okay. Sorry.
So what do you get when you purchase Azure Stack? So you get a combination of stuff. You get software from Microsoft. You get the hardware bundled together from the OEM vendors. You also get automatic support and services. So on the support side, you get both help in selecting the hardware and post-deployment support if there's any problems. We'll talk about how that's integrated between Microsoft and the OEMs in a little bit. And you also get services. So one of the important things is if you're an end customer and you buy Azure Stack, you cannot deploy it yourself. It requires the OEM to send somebody to do it. We also are starting to get some other partners that are qualified to do the installations on behalf of the OEMs. But the long and short story is you cannot do it yourself. You need to have some sort of services. There are also a bunch of services that, while not mandatory, will really help with the adoption of Azure Stack, and that's really what we should be considering here over the next couple of days. So when you buy it, you already saw this picture on the Intel slide. You're going to see it several more times. You're going to get a probably rack-mounted already system, although there are some options to get rackable Azure Stack systems. You're going to get a number of server nodes between 4 and 16. You're going to get 3 switches, one to handle just the management of the server nodes, and 2 to handle the outbound communication, like the top of rack out to the rest of the environment. They're all going to be cabled together. There are disks attached locally to the server nodes. So that's the basic hardware you're going to get. We're going to talk about all these life cycle events that are part of deploying an Azure Stack system in more detail.
I joked to that part of the slide as that's your opportunity to get to play Microsoft.
Yeah.
You know, because I get asked the question all the time, what's the SLA of an Azure Stack? I go, what's your SLA? Because in Azure, I can give you an SLA because who runs it? We do. We're manned 24/7 by, and that's our you know, our support statement. But if you're only running Monday to Friday from 9 to 5, and you're not monitoring your scale units outside of that, guess what your SLA is? Monday to Friday, 9 to 5, because you get to play Microsoft in part of that deployment of the SDK, or the Azure Stack.
It was like a lifecycle management server that was in there. Can that be run outside the stack, like on a virtual machine in compliance?
Answer 1. So there's a thing called an there's a from all of our hardware vendors except one, there's another unit in here called an HLH, or Hardware Lifecycle Host. That is part of the scale unit that you buy, and it is there to manage and monitor the physical infrastructure of the scale unit. You'll be working with that hardware vendor to either work with them to have them do some of the monitoring, because there's some dial home features where, you know, I had one customer, they got shipped a hard drive and they didn't even know the hard drive was failing in the unit because their hardware vendor got the notice that, hey, here's the hard drive, the field replacement unit for you. Or do you not have that? So that hardware lifecycle host is part of the scale unit. You can't run it on a separate pieces, but it ties into third-party integration, SCOM, and all the other things for monitoring purposes. Does that answer your question? Yes. Okay. What is the SLA or expectation of an Azure stack?
Monday, Friday, 9 to 5, so fine, that's my SLA. But if I wanted to run the stack 7/24, 365, nonstop, all the time, what's the availability expectation?
Answer number one, it depends. So we have some slides, we're going to cover this. There is a high level of redundancy that is built into the scale units themselves because of the hyperconverge. You can lose entire nodes. You can lose multiple drives on multiple nodes because we store the data redundantly 3 times. So we can get into maybe some of the specifics a little bit later, but we feel very comfortable that you can run 24/7, 365 days of the year, and have little to no interruption, providing, as long as you're monitoring this, the same kind of Azure sustainability that we have of 4 nines.
And we'll put a little asterisk on that during the patch and update cycle. But
Yeah.
Tomorrow we'll talk in detail about it because that's a very important topic.
Yeah, we've got these are running 24/7, 365 days of the year, that they're meant for that as an environment, and they can provide that workload. And to the patch and update, that's where typically people go, oh, I got to take the servers down because the patch and update, you'll see when we get through that module, doesn't impact the tenant workloads. They're just working away. Now there is a potential.
There's some wrinkles there.
Yeah. Okay.
So when you get your Azure Stack Scale unit, as we said, there's good redundancy built in there. So all the server nodes are double connected to the top rack switches. So if either of those switches fails, you will still have connectivity throughout to your environment and out to the internet. And you'll see there's only one BMC switch. So when we talk about availability, you'll see that we feel it's okay to lose that BMC switch for a while, because all you're going to lose is operator power. The users, the workloads, the functioning of the fabric of Azure Stack does not depend on that BMC switch. So that's why there's only one required in the rack. Inside each server, inside each server there is directly attached storage, and underpinning that is storage spaces direct, so that storage can be shared amongst all of the server nodes. We talked about the BMC switch, and there's interconnectivity between that switch and the internet for the call home features, and there's obviously multiple top of rack switches for redundancy purposes. Once we get to the point where you can add multiple scale units into one region, Robert said earlier that we require that those 2 scale units be from the same hardware vendor. The reason for this is because we're going to do some automatic configuration between the top of rack switches so that those scale units need to talk to each other. And don't forget that this is like a sealed unit. So the configuration of an Azure Stack Scale unit is not only installing Windows Server on these server nodes, setting up the Azure Stack Fabric virtual machines, but it's also configuring things like port level configuration for the switches, configuring the routing topology from the switches out to your infrastructure. So when you add a second scale unit to a region, the configuration of those top of rack switches has to be consistent. Does that make sense as to why we'd have them? It doesn't mean you can't put a Dell and a Lenovo and an HP and a Cisco all in the same data center. It just means that they would be in naturally different regions. And ultimately you can have multiple scale units in multiple regions, all forming a single cloud for Azure Stack, but not today.
And we're going to cover some of these points in other modules, but if you just go back to that one slide for a sec, know that each of these server nodes are identical in configuration for cores, memory, and storage. So you add capacity of the same kind by adding up to 16 nodes within a scale unit. But if you have different types of workloads, and this is going to be part of that preliminary work that you have to have with your customers, you have to understand the workloads. Gone are the days where you hug your hardware and you load it up with every memory slot with as much memory as you can, and you get a variety of drives. You can't work that way. You got to look at your tenant workloads and then build the scale units based around the workloads. So if it's a SQL database that has volumes of data that you're working with, how do I get volumes of data? Do I do it with SSDs? It's hard, it's expensive. So you might have to build a scale unit that is using physical spinning disks, versus if you're looking at web traffic and lots of, thousands of, fast transactions, you need SSDs. I can't have, oh, I'll make this half SSDs and half physical spinning drives. It doesn't work. So you build a scale unit based around a workload requirement, and then you might have another one that says these workloads go on this scale unit because it's built with SSDs and tons of cores, where this one is built more for network throughput and storage. And so that's the kind of architecture work that you do with your customers to architect what a scale unit looks like. Because of the hyper-converged environment, if you were to mix drives, it just merges them all together and makes it look like one great big drive space. So there's no way to have that tiered storage that you have in Azure currently.
So you may end up with multiple siloed Azure Stack environments just based off of what you just said.
So the question or statement is, based around the hardware configurations of it and the limitation of only one scale unit per region, I'm interpreting, you could potentially have multiple endpoints currently. That answer is correct. It doesn't mean you can't design for it to be a single region eventually when that piece comes down the way. So when I work with my customers, I say, don't use that public namespace that you want eventually as the current one, because it will become irrelevant down the way. Now, there was a couple of other questions. We'll get to them first.
So when you're dealing with these different...
So the question is there's this, tell me if I got the interpretation incorrectly. In public Azure, I just pick, and I can figure out where things are going to go, and it all works together because it's all Azure. But in Azure Stack, you have this inherent issue that based around the physicality of the servers, I have to deploy to one versus the other and not have this interoperability of, I have an app that needs some SQL and some web.
Analytics versus running, typical web workloads.
So my answer to that would be, currently that might be what you're thinking, and we have this challenge ourselves. We're going to show you a planning worksheet, and we're going to show you to base it around workloads versus VMs types that you're working with, but the worksheet has the same inputs. Because how we offer PaaS services is you deploy virtual machines, but where you deploy them is different. What I'll call the magic layer in the Azure Stack piece, there's still IaaS services that are providing web services, but on an IaaS platform that you manage as the Stack operator versus as an IaaS workload that you deploy as a work machine that you're managing and working with. So I think that...
You'll be addressing this later.
Yeah.
So yeah, I was actually kind of using it as a parlay into a different topic.
Okay.
It sounds like you're covering.
Okay, and we'll go here first and then here.
Sure. I'm curious on Windows Server 19, right? On the STN 500 IOPS, regardless of whether it's hybrid or
Correct.
12.
Yeah, it could. I would say it can get up to 500 IOPS.
Yeah.
But it's exactly the same as Azure to prevent the noisy neighbor problem, right?
But even with hybrid is flash, cache, splitting disk. You're still doing
Yeah.
SSD I/O.
Yeah.
So I/O performance, even in a hybrid, is not an issue.
Correct. It should not.
Disk
be.
reads that maybe for the performance, and that's the only little difference.
Okay, so I think we've probably talked to or alluded to some of the stuff. When you buy a scale unit, you get between 4 and 16 server nodes, direct attached storage. So secretly under the covers, these servers today are all running Windows Server 2016. They're all clustered together using Windows Server clustering. They're all running Hyper-V. And on top of that, the virtual machines run. We're using storage spaces direct to make the locally attached disks visible to all machines in the cluster or inside the scale unit. So although the end user of Azure Stack doesn't have to know that, as technologists we'll get asked that kind of question, and that's what's running under the covers today. You'll see tomorrow when we talk about patch and update, we can seamlessly, while all the tenant workloads are running, while all the user applications are running, we can migrate these servers up to Server 2019. So you will see in a future release of Azure Stack that the operating system running on these servers will change. And that's all built into the way that the patch and update cycle works. So again, as an end user of Azure Stack, you don't really need to know what's running under the covers. But for us, it's Windows Server 2016, clustering, Hyper-V, storage spaces direct, and a number of virtual machines running on top of them to provide the Azure Stack services. Obviously, we have the network switches, which we showed in the previous diagram attached to that. and the infrastructure services, the fabric of Azure Stack, are all running as a set of virtual machines. So there's around 20-ish virtual machines that will run in a scale unit that provide all the bits and pieces of Azure Stack. So they'll provide the portal website, they'll provide the Azure Resource Manager endpoint, they'll provide all this, Key Vault, they'll provide all the services that run the infrastructure, like the patch and update cycle. So to an end user, those just appear as things that you can see in the portal, or things that you can experience through the ARM endpoint, or things that you can experience by events, alerts that are being emitted from the system.
And I'll refer to it, Pat's referred to it. This is that magic layer. This is the stuff that you use, but you can't play with. Even as the owner of the scale units, this magic layer is forbidden to you to a vast majority of the degree without our assistance to get in, and the term we'll use is break the glass. So those infrastructure servers need resources. And what we're showing you here is you just don't get the capacity of 4 nodes here. You get the capacity of 4 nodes of n minus, we say, up to 2. And so this is going to be part of the capacity planning, because as you add PaaS services, there's more infrastructure rules that get added, taking away some more of that initial workload.
And you'll see in the lab environment, when you're in the Azure Stack, the ASDK single node environment, we let you see the Windows infrastructure. So you can run Hyper-V Manager and see that, hey, I have 4
domain controllers.
Domain controllers running, a bunch of VMs running. When you get a real Azure Stack scale unit, you have no way of running those tools against Azure Stack to even see that. So we sort of show you the magic a little bit in the ASDK, but in a real live environment, you can't see it. We talked about a reserve. So during the patch and update cycle, which we'll go into a lot more detail tomorrow, we take individual server nodes out of service so that they're not participating in Azure Stack anymore, and we update them one at a time. So you need to have one whole server's capacity reserved so that when a patch and update cycle arrives, you can evacuate all the running workloads off it and have your Azure Stack continue to run. So in this 4-node example, one of the 4 nodes is reserved by the system for a patch and update cycle. So Azure Stack will not let you create so many workloads that it would require some to remain on that 4th node.
Just because I get asked this question a lot, it doesn't reserve a node, it reserves the capacity of a node. So all 4 nodes are being used, but a portion of its capacity is taken offline, because eventually what we do is we drain that one, move everything off, patch and update this one, and then we move the objects back. But yeah, all the active nodes are active, but the capacity of one node's worth is taken away from tenant consumption.
I'm just going to mention that. So the infrastructure services take up somewhat less than 1 server's worth of capacity. So if you want to think about it, you need to have 1 point something servers worth of spare capacity in your Azure Stack. So in a 4-node rack, that's a fair proportion. In a 16-node rack, it's not so bad. You still only need 1.7 servers to run it.
Because adding more nodes doesn't add more infrastructure servers. The work capacity is just going to be 99% added to the tenant workload capacity.
Any question there? Capacity for these infrastructure services?
So the question is, there's a planning worksheet, capacity planning we're going to show you, that as you add more nodes, it doesn't seem to proportionately. So we can address that if you take a look at it, but the capacity worksheet takes this number that we're talking about of up to n minus 2, because for sure n minus 1 we're taking away because of the patch and update. Now, if you've got these configured with hundreds of cores and tons of memory, well, our 14 machines are still only 14 machines, only going to take a smaller footprint. But if you have these minimally configured, you could potentially use a whole node's capacity just for that infrastructure. That's why we say it's up to 2.
But that spreadsheet should take that into account.
It should take it into account.
Because if it doesn't, then it's wrong.
And this will get, I have a thing I'm going to mention at the that workload that I'm going to challenge some of our hardware vendors into, because I think that's where your flaw may be, because we preload the capacity planning tool with just some fake data. And so yes, we've got a 16 node in there, we've got a 4 node, but they're not configured the same way. So adding more of these 4 nodes compared to the 16, you may see an incongruent value that you're dealing with, because it's not a true measurement from a vendor what you're going to get. So I think that that's where you may be seeing that disconnect.